Hey guys, today we're going to be adding and subtracting decimals up to the hundredths place. I'm going to show you what it looks like on a model, and we're going to assess the reasonableness of our answers using estimation strategies. Before we get started, there's one really important nugget of information that I'm hoping you remember back to my comparing and rounding videos where we said that we can put zeros at the end of any decimal number and it doesn't change the value, it just changes how it looks. So for example, 4/10 would look the same as 40 hundredths. And let me show you why real quick, just as a reminder. So each tenth, this is in the tenths place, 1/10 is one big long rod that looks like this. And it's because there's literally 10 of them in there. So if we were going to shade in 4/10, we've already got one. So now 2, 3, and 4. However, on the other side, we've got 40 hundredths. One little hundredth looks like that because there's quite literally 100 of these in the entire whole. So if we were going to color in 40 of them, this is what it would look like. So that's kind of a better visual of why we can put those trailing zeros at the end and they don't make a difference. They still show the same amount of the whole taken up. So here's our first problem. We've got 17 hundredths plus 35 hundredths. Fortunately, they're already in the same place value. What I mean by that is they've already got a tenths place and a hundredths place. You'll notice that on the same one as well, a tenths place and a hundredths place. So that makes our job really, really, really easy. If we wanted to show what those would look like on a hundreds grid, it would look like this. 17 hundredths. So because this is a hundreds grid, we would just need to color in 17 of those little squares, or we can use what we know about place value. We know that there's a 1 in the tenths place, so we can just go ahead and color in 1/10, and then a 7 in the hundredths place, so we would just need 7 additional little hundredth squares. So that's what 17 hundredths would look like in a hundreds grid. Now let's see what 35 hundredths would look like. Now, part of our standard says that we need to be able to assess the reasonableness of an answer based on estimation strategies. So to estimate, we're going to round both of these values to the nearest tenths place and see what we would get. So 17 hundredths would round up to 2/10. 35 hundredths would round up to 4/10. If we were going to add 2/10 plus 4/10, that would give us 6/10 or 60 hundredths. So whatever answer we get should be very close to that answer. Now, because we're adding, we need to show what these two values would look like together. Okay, so first I'm going to put in our 17 hundredths. Now I'm going to put in our 35 hundredths. So to add my 35 hundredths, what you'll notice that I did is I went ahead and put in my 3/10 with an additional 5 hundredths. I did 3 on this side and then the remaining 2 over on the other side. As far as an answer goes, if we were to look at our hundreds grid, we know that each rod, each column is worth 10. So we've got 1/10, 2/10, 3/10, 4/10, 5/10, plus an additional 2 hundredths, 5/10, 2 hundredths, or if you literally just counted up all the little squares that are colored in, you would have counted 52. So the answer to our problem here, 17 hundredths plus 35 hundredths is 52 hundredths. It wasn't spot on with our estimate, but it was pretty close to 60 hundredths. So that should tell us that since our estimate is very close to what we got, our answer is reasonable, it makes sense. The next problem I want to show you is 8/10 plus 25 hundredths. Again, I'm going to assess the reasonableness of our answer by using estimation. Since 8 is already in the tenths place, I'll go ahead and keep it 8/10. I'm going to round 25 hundredths up to the tenths place. 5 tells 2 to go up to 3, so it rounds up to 3/10. So our estimate should be 1 and 1/10. Because our answer is expected to exceed 1 whole, then I went ahead and put 2 hundredths grids in because we should be filling up more than one. First, I'll go ahead and put in my 8/10. Now, if you remember with addition, order doesn't matter, but I personally think it's easier to go ahead and put the bigger value in first and then worry about the smaller value afterwards. And it's good practice for subtraction because order does matter with subtraction. So my 8/10, if you remember that 1/10 is just a column, so I just need to fill in 8 of those. Okay, I've got my 8/10. Now I need to fill in my 25 hundredths. And then I don't have any more space left in this first hundredths grid, so my 5 hundredths extra are going to need to go into the second one. So our answer using hundreds grids, this entire whole, so that's going to be 1 and, because we've got a little bit extra, and that little bit extra is only 5 hundredths. The hundredths place is 2 away from the decimal, and we're going to put a 0 in here as a placeholder for that 5. So our answer to 8/10 plus 25 hundredths was 1 and 5 hundredths. Our estimate was 1 and 1/10, which is very close. It's only 5 hundredths away, so our answer does make sense. So now I want to show you how to do that problem and get the exact same answer, but without using a hundreds grid. The problem that we were just given was 8/10 plus 25 hundredths. When we're used to adding and subtracting, we're very used to putting them just right on top of each other. And we definitely can do that with decimals as well. The most important thing about adding and subtracting decimals this way is to make sure that you line up your place values. So what I mean by that is just like we do with whole numbers. If we had a number in the tens place and a number in the ones place, we wouldn't stack them on top of each other. We would put the ones with the ones, the tens with the tens, so on and so forth. So decimals have to be the exact same way. The easiest way that I've found to do this is to line up the decimal points first. So here's what I mean by that. I'm going to take both the decimals out of my numbers. So now I'm going to go ahead and fill in everything else about that number around the decimal point. So there was a 0 in the ones place, 8 in the tenths place. And then for our second value, we had a 0 in the ones place, 2 in the tenths place, and 5 in the hundredths place. So this looks super confusing because we're not used to looking at something that has blanks where digits are supposed to be. So this is where we're going to pull out that nugget of information from the beginning of the video where we can put trailing zeros at the end of a decimal value and it doesn't make a difference. Because right above this 5 in the hundredths place, we've got an empty place value up top. And I always tell my students that this just looks disgusting. We don't want it to look like that because that's not how we're used to seeing it. So we want to put something in that empty place value, and what's better to go there than a 0? So now that looks just a little bit better on our eyes. We're not trying to add where there's nothing there. And now we can just go ahead and start in the smallest place value like we always do when we're adding or subtracting, and just add like normal. The only thing I need to remember to do after this is drop down my decimal point. And there you have it. We have the same exact answer that we had when we did it with the model. 1 and 5 hundredths. Now let's try a subtraction one. So here we've got 1 and 83 hundredths minus 3/10. First, let's go ahead and estimate so that we can check our answer for reasonableness. 1 and 83 hundredths would round down to 1 and 8/10. And then we've got 3/10 that's already in the tenths place. We're going to leave it like that. If we were to subtract 1 and 8/10 minus 3/10, we would be left with 1 and 5/10, so that's somewhere around where our answer should be. If it's not, then we know that we did something wrong somewhere. We need to go back and check our work. So remember, with subtraction, it is different with addition, where when we're subtracting, we've got to start with the bigger value. Hopefully you guys remember back to our comparing skill that 1 and 83/100 is much bigger than 3/10, so that's what we're going to go ahead and start with. I've got 2 hundredths grids here because this value is bigger than 1 whole. It's already got a 1 in the ones place, and then we've got a little bit more than that, so we're going to be filling up more than 1 hundredths grid. So my 1 whole right here, that's the entire hundreds grid itself. So I'm going to go ahead and shade in that entire hole. Doesn't have to be perfect, but there's my 1 whole, and now I need to fill in the other hundreds grid with my 83/100ths. Okay, so I filled in my grids showing 1 and 83/100ths. But out of those 1 and 83/100ths, I need to take away 3/10. Or we know that that's the same thing as 30/100ths. So I need to take away 30 of these little squares. Or I know that 3/10 is the same thing as 3 columns. So I'm going to go ahead and get rid of 3 columns that are already filled in. So imagine that blue part is where I took away. That's my subtracting. So I took away 3 of the tenths that were already there. And now we just need to see what we're left with. So after I've shaded out those 3/10, I've still got my 1 whole. This right here represents 1, 2, 3, 4, 5 tenths. And then these 3 little hundredths that were left over. So our answer to 1 and 83/100ths minus 3/10 was 1 and 53/100ths. Our estimate was 1 and 5/10. We were only 3/100ths off, so that's pretty close. And our answer checks out. And now I want to show you that same problem, solving it by just regular subtraction, stacking them on top of each other without the hundredths grid. So remember, with subtraction, we do need that bigger number on top. Our bigger number here is 1 and 83/100ths, so I'm going to put him right on top. And then remember my trick as far as lining up the place values. If you line up the decimal, everything else will be lined up. So I'm going to go ahead and drop down my decimal right under the one I had above it. And now I'm just going to fill in everything else around it. We had a 0 in the ones place, a 3 in the tenths place, and then we're left with that really awkward space that we have. I'm hoping you guys remember that nugget of information, that we can put a 0 there. And now we can go ahead and subtract like normal. Don't forget to drop down our decimal. And there you have it. Our answer is 1 and 53/100ths, which is the same exact answer we just got before using the hundredths grids. This skill really is a good one to know. Not only do you need to know it for 5th grade, but you're going to need to know it when you get older and start dealing with money. So this is a really useful one to know how to do. I've only been giving us numbers that are within like 1 or 2 ones. So I want to make the numbers a little bit bigger now, a little bit more challenging for us. The first one I'm going to give us is, so if we had 19 and 7/10 plus 2 and 35/100ths, now we're dealing with numbers that are just a little bit bigger. But we can solve them the exact same way. All we need to do, even though it's not necessary with addition, but we want to go ahead and be in the habit of putting that bigger number on top. Our bigger whole number is definitely 19. So that means that's going to be our bigger value. It should go on top. Our smaller value, 2 and 35/100ths, goes right underneath it. But I see a lot of this. Then kids will go ahead and add this way, and they'll be confused about where their decimal goes, and they will end up getting the wrong answer. That's why I say over and over and over again, make sure that you're lining up your decimals. Now we've got that awkward space there where we don't have anything in there, but remember that we can put something there, and it's a 0. Now everything's filled up like it needs to be. We can go ahead and just start adding. Don't forget to drop down the decimal. And our answer is 22 5/100. Last one I want to show you is with 3 add-ins, all with different place values. The first one ends in the ones place, the second one ends in the tenths place, and the third one ends in the hundredths place. Still line them up according to place value, just like before. Go ahead and put your 3 decimals in, because even though we don't see a decimal in this number, there is always a decimal after the ones place. So 37 would look like this. 1 5/10, 6 45/100. So we've got all our values in, but we need to add some zeros in for sure. The biggest place value we have is going to the hundredths place, so we want the others to go to the hundredths place as well. And we'll just drop zeros in where those red lines are. Now it's a lot easier to look at, a lot easier to add it, in my opinion. Our answer for that one would be 44 95/100. I really hope this video was helpful, guys.